Dr. Mike Cheadle is an associate professor at the University of Wyoming in geophysics and magmatic processes. He came to Wyoming from England, and his definition of a cruise is likely very different from yours. He'll tell us how we understand more about the moon and Mars than we do about our oceans, and he does that right here at the University of Wyoming. Dr. Mike Cheadle, next on Wyoming Chronicle.
Funding for this program was provided in part by the Wyoming Public Television Endowment and viewers like you.
Small step for man, one giant leap for mankind.
We actually know more about the topography of the moon and the Mars than we do actually of the seafloor itself. I'm a geologist that studies the rocks on planet Earth, and my big interest is studying the oceans, because the oceans are one of the last frontiers for exploration. Something like 70% of the Earth's surface is covered by ocean, and so 70% of the Earth's surface is made of this ocean crust, and we don't really know how it forms, simply because it's so difficult to get down there. So my interest is to go to the middle of the oceans, go down or send robots down there, or actually go down in a submarine and collect the rocks to try and understand how oceanic crust is actually made. So Peter Deep is in the southern Pacific Ocean. This place is so remote. 23 years ago, there'd been a single dive by a French submarine that had found one of these hydrothermal vents. Nobody had been back since. For all we knew, it could have died or whatever. And so we went back there and we dropped our autonomous vehicle, which basically maps the seafloor at 1 meter resolution. And it really was one of those eureka moments. I will remember it for the rest of my life. I was given the map, and you look at the map on the computer screen and then you zoom in, and what you begin to realize is that there wasn't just one hydrothermal vent, there were 50 hydrothermal vents. And we found that of all those 50 chimneys, something about 8 were basically teeming with life and erupting water at 378 degrees C. And the whole ecosystem down there living in total darkness, from the bacteria to the shrimp, mussels, fish, brittle stars. You know, one of the ideas is way back, literally thousands of millions of years ago, that the Earth was a barren planet, but there might have been water, there might have been volcanic activity, and then somehow life basically grew in that environment. And these hydrothermal vents, people think that those might be good analogs for how life first started on Earth. So we actually did sample some pieces of the hydrothermal vents.
This was grabbed by the robotic arm and sampled. This is a cut piece of a similar vent structure, and this is just where the fluids have percolated through the rubble at the base of a chimney, and you can see all of these sort of iron sulfides.
So we picked up something like about 450 samples, which is an amazing amount. And so those rocks will actually provide many, many years of research. And so some of the students that came with us are doing their master's projects and PhD projects on those rocks. And it's understanding those rocks that's going to tell us the story of how ocean crust forms. Imagine if you were the very first person to be walking on top of the snowy range. You know, the very first person to be looking at the rocks up there. Very first person to be looking out across the plains. You know, we can do that in the oceans. They are one of the last frontiers of research on planet Earth.
And as we continue with Wyoming Chronicle today, it's our pleasure to now be joined live, not on a ship, with Dr. Michael Cheadle here from the University of Wyoming. Dr. Cheadle, welcome to Wyoming Chronicle.
Thank you, Craig.
Dr. Cheadle, or Mike,
Yeah.
if that's okay, we had a chance to see the trip that you took to Peter Deep, and we'll talk more about that in just a little bit. But first, give us a sense of who you are. You were born and raised in England.
Indeed.
And had a strong enthusiasm for geology when you were young.
Yeah, so, I think it's one of those things when I was at school, Craig, you take a bunch of subjects. And I fell in love with geology. I was lucky enough to have a geography teacher who was a geologist by training. And even at that point, at 12 years old, I suddenly decided, well, geology might be for me. And I was lucky enough to be able to follow that track through, at each stage to continue through. And then I went through university.
How did one do that as a 12-year-old? What grabbed you at that time?
The thing that excited me the most is that was way back in the late 70s. And it was a time when, just after this topic of plate tectonics was discovered. And so, geology as a subject went through a revolution in the 60s and 70s. It really became a science. And what happened is people realized that there was a grand unifying theory to explain how mountains formed and how the ocean basins formed and how volcanoes work, or at least some theory to put all that together. And so, you saw this thing on TV shows, Nova and things like that. And at that time, I was captivated about it, understanding how the mountains out the window really worked. And I've just been lucky enough throughout my career to actually continue in that large-scale subject of understanding how the whole planet works.
You got your undergraduate degree in England at Oxford.
Yeah.
And then you came to graduate school at Cornell?
Yeah. So, when I was an undergraduate, I thought, well, wouldn't it be great if I could go to another country and carry on studying geology? And so this really exciting program at the time called the COCORP project, which was Consortium for Continental Reflection Profiling. And what had happened there is some bunch of academics at Cornell had realized you can take the techniques that oil companies use, but instead look for oil and investigate the whole structure of the Earth's crust. And so it was a big project at the time, and I was lucky enough to go and be a part of it. And so I went and did that for a while. And then as a Brit, what happened was the many countries around the world followed and said, look, we've got to do this too. And the French did it, the Spanish did it, the Germans did it, the Canadians did it, and the British did it. And so here was there were actually two of us, two British students at Cornell, and we were both kind of brought back to England to partly help start up the similar project in Britain, because we'd learned that experience.
And you continued then and got your PhD actually in
Cambridge,
correct?
So I did that for a while, and then I decided, well, I got to change. And, and so I was lucky enough to work with a professor called Dan McKenzie, who was who's still alive, but he was one of the leaders of this big plate tectonic revolution. And so I completely changed track and started to look at how you get the melt out of the earth that forms a volcano. And so I did a PhD on mathematical modeling, trying to understand how volcanoes work. And that led me to my first job, which was in Liverpool University. And then about 9 years later, I came to the University of Wyoming.
And how did you come here? We're on campus. We're in the Geology Museum here at the University of Wyoming. What brought you to Laramie?
So two reasons. One, there were just so many more opportunities in the US. The US is a bigger country. And, one of the first things that hit me when I'd been here was that in this country, you can really attack basic science problems. There is the money available to be able to explore the world and do things for the first time. And in smaller countries, that's limited. So the opportunity for research is just amazing. But the other was a personal reason, in that my wife was already a professor here. Oh, sorry, she wasn't my wife then, but I knew a professor here, and we were beginning to know each other well. We were partners, and we were lucky enough to interview both in Liverpool, where I worked, and Wyoming, where she worked. And basically, it was a very easy decision to come to the University of Wyoming.
Back to your ocean work.
Yeah.
You've been on 11 cruises.
Yeah.
Your concept of a cruise, I'll tell you, is very different than mine. with obviously the great research that you do. How did you end up wanting to study this work in the ocean? And it strikes me as this isn't something that someone from Wyoming would end up doing, maybe if you were at a coastal institution.
The magic word is exploration. And so the follow on, I remember as a grad student that I told myself I would never go to sea because it seemed like too much hard work and I wouldn't do it. And then so just before I actually came to Wyoming, I got invited to go to sea. And I thought, well, why not? Let's go and see what this is like. And so one of the first things is you get a license to travel the world. You mentioned 11 cruises, but they often leave from exotic places.
Easter Island on the one we saw
Easter
earlier.
Island, Reunion, Mauritius, South Africa, the one that I just came back from. So you get this chance to travel. But the real reason is once you're on that ship, or the science team that's on that ship, you are really going to places that nobody's ever been before. You're exploring the ocean, and there's a total buzz from deciding what to do. And so you have submarines, you can dredge up rocks from the bottom, but it's totally evolving. The fun thing is you might write a proposal to say, look, we're going to go and look at this. When you get there, you realize you really did not have any idea what it's like. And then you're making this program as you go along to explore the bottom of the oceans.
So not only are there scientific reasons to change it up or make some real-time decisions, weather and many other things impact what
Indeed,
you're able to do.
the biggest challenge for me, and it was one of the most interesting and fun things to do, but also stressful. So in the last one cruise, the one to Pedo Deep, I was actually one of the chief scientists. And so I was the guy that was making the decisions. And, and it's one of those things that you don't really appreciate until you get on the ship. And then you realize these people that run the ship are expecting me to tell them what to do. It's like, who are you talking to? But then you're trying to juggle all this stuff. And so, the trick is, a cruise is expensive. You need to run 24 hours a day. You can't afford to stop, or you don't want to stop because you're just then wasting time. And on that cruise, we had 2 different submarines. We were also trying to map the seafloor. And the background to the submarines is they can only be down for a certain amount of time. They have to come back to recharge their batteries. The people that are running them at times need time off.
Sure.
And then, as you mentioned, the weather. So you're looking at the weather forecast. You're trying to decide, okay, we'll put this submarine down for 24 hours, then we'll bring that back and put the other submarine down. And you're trying to juggle this, and eventually it gets to the point where you're running out of time. And so it's a tremendous, both fun and a challenge to try and organize all this stuff. And all the people running it and keep everything going, juggling all those balls at the same time and get as much done as you can.
And there's also a lot of work you had to do prior to leaving Easter Island. That you had to order buckets, you had to make sure you had food, and everything about the cruise was for you.
You mentioned the cruise, and so the ship itself is essentially a Navy ship. And so it is very much like that. The chief scientist's cabin is quite nice, but every other cabin is, it's just a steel cabin with a couple of bunk beds and so on and so forth. But basically you get the ship, you get the people that run it, you get the people that run the submarines, but that's all you get. And so you have to provide everything from pens, sticky notes, and all the scientific equipment that you might need, microscopes, you mentioned buckets to put the samples in when they come. And of course, you've got to guess how many buckets you need. And so we took 200 buckets and didn't use them because we just didn't really know. But to make all this work, we actually hired a U-Haul van and put all this stuff in the back of the U-Haul van in Wyoming, and then drove in October all the way to the Oregon coast and actually loaded the ship in Oregon.
So continuing on with the science.
Yeah.
What are you learning? What has changed in what you thought to now what you're thinking as you're moving forward here?
There's 2 parts to the science. Every proposal requires a specific question. The cruise we were last on just a month ago, and
this is to the Indian Ocean.
This is the Indian Ocean. There's a huge rise in the seafloor, huge topographic bump in the seafloor called the Marion Rise. And the question is why? And we simply don't know. And moving back one step, the fun thing about exploring the oceans is that literally we haven't done that much. As everybody probably knows, the oceans cover 70% of the the Earth's surface.
And as we learned in the run into our discussion, we know more about Mars and the moon.
Exactly.
Yeah.
And so in terms of the topography of the seafloor, which reflects the geology going on, we know much less, as you said, than the Mars and the moon. And it turns out that we know, we've mapped it to that level in about 15% of the 70%.
Before we go on, talk about, we have satellite maps.
Yeah.
And then we have maps that you were making down to 1 meter resolution.
So, one of the cool things about the geology of the seafloor is that if you can see the topography, you can predict the geology. Because the topography of the seafloor down there is either going to be a big volcano, it's either going to be a big mountain formed by some sort of big fault, or it's going to be some massive landslide deposit. Really, that's all that can happen down there. And so if you can get a very accurate picture of the seafloor, you can interpret what's going on. Is it volcanoes? Is it big faults? Are there big landslides? So the question is, how do we get that map? And so one of the things we can do is we can use satellites to literally measure the surface of the sea. But the surface of the sea reflects the surface of the sea floor because of gravity. If you've got a big mountain at the bottom of the ocean, then that causes a bulge in the sea surface. And so we can use satellites to make accurate maps of the sea surface, and then we can invert that to get maps of the sea floor. But that only gives you a resolution of about 4 or 5 kilometers. So you could, take a big mountain and basically put it down the ocean floor. Then if it's smaller than 4 or 5 kilometers, you won't know it's there from those maps. And so the next scale of thing we can do is actually sail a ship there and effectively use sonar, or think about it like radar, to map the seafloor from the ship. And that will give you something like about 60 meters resolution. So in doing that, we can suddenly see whether that mountain is a volcano, or whether that mountain is a big fault-controlled mountain, or whether there's big landslides. And then you can go, the next step is you can put down one of these autonomous vehicles to the bottom of the seafloor. And so these things are like drones. Mm-hmm. And so you basically can put them down. They can stay down for about 24 hours. That's purely battery life. But as you program them to basically plow the furrows of the field. And what they're doing is mapping the seafloor at something like a 1 meter resolution. So then you get to see the rock outcrop, or as you saw in the video earlier, we get to
the aha moment. Exactly,
these hydrothermal events. And for my scientific career, and you saw it earlier, it really was one of the eureka moments for me. We decided we were going to put the autonomous vehicle down there, the submarine, and make a map. And then, you eagerly wait it coming back, and the people that run it eventually give you a memory stick with some data on it, and then you plug it into the computer. And I remember looking at the map, big scale, from afar, and you went, and I thought, that's a nice map. And it really was the eureka moment, is on the computer, you zoomed in, and then suddenly you could see all these hydrothermal vents.
You were broadcasting back to students, even here in Wyoming, while you were on the ship.
Yeah, so one of the things that we try and do is bring this experience to literally people around the world. And so both on that cruise to Torpedo Deep and the cruise we just did, we did something like on the order of 30 live two-way broadcasts to students around the world. And actually in Wyoming, we did geological societies as well. Call out, we did the geologists of Jackson Hole. We did the Wyoming Geological Association. So we actually did, formal lectures from the boat in the middle of the ocean to these geological societies. Mm-hmm. But the more fun thing was talking to the students. And we did everybody from kindergarten through to college students, and to places around the world. On this last trip, we did schools in Indonesia, schools in Europe, and of course schools in the US, and with a big, preference for doing schools in Wyoming. And so, it's one of these things you can now do. And so we would do these 50-minute broadcasts two-way, so the students can ask us questions. But the biggest thing is just giving these school children an insight in what life is like on a ship, what it's like to be on a ship, what it's like to be in the middle of an ocean, and what it's like to do groundbreaking science. And again, I can't stress enough, the whole exploration thing of just being the first people there.
You've taken students to the Atlantic Ocean, the Pacific Ocean, and the Indian Ocean from the University of Wyoming.
Yes, yeah.
Found it remarkable that what you have brought back will now be fuel, so to speak, for graduate research for years to come.
Yes, indeed. So, one of the questions said earlier, and going back to it. So, what are we doing out there? We're trying to answer fundamental questions. And so back to the Pedo Deep cruise again, one of the things that's happened, we've been exploring the oceans, the geology of the oceans now for 30 or 40 years. And it's easy to pick a rock up from the surface, from the seafloor, really. But what we're interested in here in Wyoming is, what does oceanic crust really look like? And so oceanic crust is this layer that underlies the ocean, which is 7 kilometers thick. We've collected a lot of rocks from the top, but we have very few rocks from within it. And so you can find a few places in the oceans where there's a big fault that gives you a crack or a cross section through the oceanic crust where you can sample those rocks. And that's what we were doing on the Pedo Deep cruise. That was the real science we were literally doing the most detailed sampling that's ever been done to give you a cross section through that oceanic crust. And we brought back 40 or 50 rocks. And so all those rocks need to be studied. And so we have 2 graduate students here now, other graduate students at Scripps in San Diego, Scripps Oceanography. And those students are working on their rocks for those theses. And as you said, it is such a unique collection that I would foresee people working on those rocks for literally many years to come.
When I think of the geology department here at the University of Wyoming, I think about mineral research, energy research, those more applicable types of things. Are students surprised that it's really much more than that?
I think the students probably less so because, they get introduced to the whole spectrum of geology. But, one little story was that we got invited when we came back to talk to the Department of Arts and the College of Arts and Science Board of Trustees. And so, we gave our little story about Pedo Deep and all the things we did. And, one of the comments that came back there from the Board of Trustees is, I didn't know you guys did that kind of stuff.
I can imagine. You're an award-winning teacher here at the University of Wyoming, yet you also do all of this research. Is it hard for you to balance those two things?
No, I think, the whole reason we're here is to teach. And, as much as, and you can tell, as much as I'm excited and, and really enjoy going on these cruises and exploring, one of the biggest things is taking the students, taking students who've, maybe never even been out of the country. And, so on the Pedo Deep trip, as you mentioned, we took the students to Easter Island. And on top of that, the students said, well, what the hell, we're going to Chile, let's go to Patagonia. And so these students, one of the students had never even been to the East Coast, and there they are in Patagonia, and there they are in Easter Island. And so, I think the most important thing I do is really teaching the students, whether it be opportunities on these cruises, but also in the classroom. And, because they are the future. In some ways I am the past, or I'm soon to be the past, but, our future is educating the students and have them to go on and do great things.
But you still have plans. What's up next? What's the next cruise?
Wow. So 2 answers to that. There's a reality and the dream. And so the reality, there is a German cruise. So I mentioned this last cruise was a multinational one. And so part of the deal is the National Science Foundation in the US funded the cruise I was just on. And so the German equivalent have funded a partner cruise. And so there'll be a cruise with basically the same people going out, but on a German ship. And that will be next year. And so, that will carry on that exploration. And just to interject there, the fun there is the Indian Ocean is a place that we really have not looked at very carefully. And it's partly just because where it is. It's way away from Europe, it's way away from North America. Also down there, you're in the so-called roaring Forties. So the weather is really bad, or the seas can be really rough. And so part of the fun is people haven't been there that much. And so again, it comes back to being the first people to go there and explore. And so that's concrete. But to finish off my career, I have 2 dreams to write 2 proposals for 2 more cruises to go and again answer some of these fundamental questions about the nature of the Earth's crust. And so one of the big projects that's been around for 50 years is to drill a hole all the way through the crust into the mantle. And so that would be a hole that's 7 kilometers deep. And people have dreamed about that for 50 years. People actually started during the 60s when we were going to the moon. And the very initial people even got telegrams from President Kennedy, congratulating them on their progress. But their progress, it's such a difficult problem that we've never achieved that. And in truth, I'm not sure we ever will, but we can do what we did at Pedo Deep. We can take submarines and basically do it a different way, and that's look at one of these cross sections through the crust. And so the end of a wonderful end to my career would be to go and map this thing called the MOHO, which is short for Moravisic, who is a Croatian scientist that discovered the crust mantle boundary 100 years ago.
A lot of research all over the world. How's this funded?
A lot of it comes through the National Science Foundation. I mean, the US is very lucky in that we have the National Science Foundation, which puts a lot of money into science. And, I thank them most gratefully. Plus, of course, the support that comes from places like the University of Wyoming. I mean, we get money from the University of Wyoming to help the students go out there to participate in the cruises. And so in a way, we're very lucky.
Is this funding at risk in the near future? Do you see it is it stable?
There's always the question, the big question of, how much funding should the country put into science?
Well, Dr. Mike Cheadle, it's just been a pleasure to visit with you. Your enthusiasm is just awesome.
Thank you.
And I really appreciate you joining us today on Wyoming Chronicle.
Thank you very much, Craig.
Funding for this program was provided in part by the Wyoming Public Television Endowment and viewers like you.